Good morning, students. Yesterday we have seen symbols of the sets. Today I'm going to teach types of sets. Types of sets. Yeah, in these types of sets, many more are there. But today I am saying few types. In that, the first one, already we have discussed about this one, first one, empty set, and also the another names of empty sets, void set and null set. Void set and null set. Right now, the first one is empty set and also called as void and null set. Void set and null set. Right? This is already you are discussed in symbols. Right? So this is a symbol pi. Right? Next one, Singleton set. Second one, Singleton set. Next, third one, Finite set. And fourth one, Infinite set. And fifth one, Universal set. Universal set. So these five today we are seeing. The first one is empty set, and the second one Singleton set, and next one, third one finite set, and fourth one infinite set, and fifth one universal set. Right? So see one by one. The first one is empty set. So empty set, it is generated by which symbol? Like this. Empty set, it is generated by like this symbol. Yeah, it is called as pi. Yeah, it is called as pi. The symbol name as a pi. So what about empty set? Yeah, in that is also there. Empty set means empty only. Empty set means empty. The set which does not contain any elements or objects. A set which does not contain any elements or objects. Suppose if I take like this set, in this I am keeping one dot. It is not an empty set. Why? Because I am keeping what here dot. Dot means it's having some element, so that's why that is not a empty set. So empty set means there is nothing in curly bracket, means even one bracket is also not appears. That means anything, so bracket, numbers, numericals, whatever, in single dot also, single point also, so never put in that curly bracket. So that is known as what? Empty set. So empty set, we are showing this symbol. The symbol is named what? Pi. So empty set is denoted by this symbol as well as empty curl bracket. So right now, empty curl or flower bracket. This is also empty set and this is also empty set. So right, for sake of understanding, So we are taking or we are working on empty set. Some more examples for understanding. So first one and second one and third one, I'm saying the first one I'm taking like this, and second one I'm taking like this, and third one I'm taking like this. So in this three, among three, which one is empty set? The first one is not empty set. Why? Because in curly brackets having one element. So in curly brackets having one element, that is pi. Sir, actually that is also pi, means it won't consider, means doesn't mean it is. So which elements are having in curly brackets, those are called objects, otherwise elements. So that's why this is an element. So that is, first one is not a set, first one is not a set. The second one is obviously right, it is an empty. Why? Because there is nothing in curly brackets. And next one, third one is also correct. Why? Because it is a symbol, obviously, so we can denote it by this symbol empty set. So that is correct, right ma? I think it is clear. So right, so empty set is nothing but which doesn't contain any element or object. Element or object means anything, whatever, numericals, symbols, whatever it may be. So that is empty set. Empty set is denoted by this pi symbol or this curly bracket with an empty, not anything in that. With an empty you take, that is an empty set, right? So this is a empty set, right? We'll go for next one. So empty set symbol already we have denoted, so we are seeing that is, so pi, otherwise this is curly bracket and okay na, which is an empty, right? This is the symbols for empty set. Empty set, so having another names, that is void set and null set also. And next one, the very important property and very important note, that is what, empty set is a subset of every set. So already we have seen that is, so empty set is a subset of every set. So in the previous class we already discussed about this one. So empty set subset to every set, whatever it may be, and also pi subset to pi also, that is obviously is true. So empty set is a subset to every set. Empty set is a subset to every set, right? The next one, next one is also one statement. It is also most important. Every set is a subset of itself. So yeah, it is trivial, obviously correct. That is what, A subset to A. Why? Because I am taking like this, so set of 1 2 3 elements. So obviously A contains those elements present in the same set. That means A is subset to A, and B is subset to B, and C is subset to C. So every set is a subset of itself. So right, it is true. So but it is very important statement or very important note, so that's why you should remember. Okay, yeah, I am giving two, still now I am giving so two statements. The first one is empty set is a subset to every set, and second one is every set is a subset of itself, right? The next slide. Yeah, this first one we are seeing actually the types of sets. In that first one, empty set is over. Yes, we have finished that one. The next one, the second one, actually this is the second one, the second type, singleton set. Singleton set. I hope it is clear. Why? Because in that only single means only one, mono, right? Singleton set means a set consists of a single element. So right, single element, only one element. Single means what? Only one, or mono, right? One or mono. Yeah, for illustrative, for examples I'm taking like this. This is now this is actually empty. I'm keeping only one element, 0. Now it is singleton set. And next, one more example. I'm keeping 6. It is also singleton set. So right. So if I take like as x, that is also singleton set. If I take another example, set of y, that is also singleton set. So singleton means so which has only one element. A set consisting of single element. Single means one or mono element. Right, clear? So this is the singleton set. Right. The next one. Next one is third type. This is it. So third type is finite set. Finite set, a set consisting of finite number of elements. So finite number of elements. Finite number of elements. Right now? So the set consisting finite number of elements, right? This is the third type, the finite set, a set consisting of finite number of elements or objects. Finite means which is countable, right? For example, I'm taking like this a equal to set of collecting of 1 2 3, right? In that example, so just 3 elements are there, so obviously so it is trivial to count. So 1 2 3, just is it, so it is a possible to count, so nothing but it is a countable. So countable means that is finite. So right, countable set or finite set, whatever it may be, so both are same. So finite set means so which consisting of finite number of elements. So if I take like this 1 2 3, I'm putting what here, dots. So what I'm putting, what, dots, right? Now I'm putting as a dots. So now Is it finite set? No. Why? Because these dots indicates infinite numbers, means which are going up to where? Infinite. So that's why it is a infinite set, not a finite set. So that's why it is a infinite set. So finite set means only finite number of elements. So in that, having or present only finite number of elements, that's why it is a finite. So if we keep after elements, put 3 dots or whatever, how many dots are no need, but 3 dots, at least 3 dots means, so etc means what? That is, it indicates going infinite. Infinite means that is also infinite sets. Okay, this is the third one, finite set. So we have finished. Next one, infinite set. So already we have discussed just now. Infinite set, a set consisting of infinite number of elements. Infinite number of elements. A set consisting of infinite number of elements. A set consisting of infinite. So just now I was given, that is, so right, 1 2 3 4, and keeping like dots means that is a infinite set. Otherwise we have many number of examples. Natural number, that is also infinite set, and z, that is also infinite number, infinite set. Real numbers, rational, irrational. So right, so all are infinite sets. All are infinite sets. Natural numbers, whole numbers, and integers, rational or irrational, and real numbers and complex numbers. So all are what? Infinite sets. So infinite set, right? No? So these are the examples of infinite sets, right? These are the most important examples of infinite sets. The next one, so still now, so we are seeing what? The first one, empty set. The second one, singleton set. The third one, finite set. Fourth one, infinite set. The last one is, fourth one is universal set. Universal set, it is denoted by, otherwise symbol is U, capital U, otherwise small mu, small mu, otherwise like big U, right? No? Big U or small u. These are the symbols. Otherwise the universal set is denoted by these symbols, right? And so what is universal set? A set which consists of all the sets under the consideration. So most important, so consideration, we are considering what here? So the universal set means not universal like this in solar system, it is different from that, is right. So the mass in mathematically in set theory, it is quite different. I'm taking a equal to 1 2 and b equal to 3 4 5, b equal to 3 4 5. right? A equal to 1 to 3 and B equal to 3 4 5. In this I am consider two sets A and B under the consideration, means the set which consists of all the sets under the consideration. All the sets means here I am taking just only two sets, means all means here two sets. In that I'm writing now universal set means 1 2 3 4 5. This is a universal set for our consider sets. Why? Because in this problem only 5 elements. If I take C, so in that 5 6 7 means whatever the universal set means 1 2 3 4 5 6 7 only. It has to be changed. In the previous problem I'm just okay, I consider two sets. In that universal set up to 5 only, but I am taking what extra set, that is C, some more elements 5 6 7, it is also included, so you has to be changed, means so universal set which has changed and that depends on the problem and that depends on the sets are considered sets. So that's why, so most important, the universal set, a set which consists of all the sets. I'm taking here three sets, all means here three sets, all means here three sets. In the three sets, whatever having those elements, you should write in big sets, that is called as universal set. That is called as universal set, right? So this is a universal set, right, ma? So universal set symbol like U or mu, U or mu, U or mu. So universal set means a set which consists of all the sets under consideration. This is what universal set, right, ma? So still now we have finished all those things. Just we have seen what ma types of sets. Just I am recalling once again types of sets. The first one is empty set and also known as void set and null set, and the second one is singleton set, third one is finite set, fourth one is infinite set, fifth one is universal set. And the next one, empty set, means a set which does not contain any element or any objects. So it is denoted by pi, otherwise the empty curly bracket or flower bracket, right, ma? So this is empty sets, first type. And also we have taken some first note, empty set is a subset of every set. Empty set is subset to every set, right, ma? Empty set symbol what, ma? Pi, otherwise empty curly bracket. And the next one, this is also no very important note. Every set is a subset of itself. Every set is a subset of itself. A is subset to A, and B is subset to B, and C is subset to C. So whatever. So if it is set, means that is subset to itself only. So right. So next one, the second type. This is the second one. The first one is empty, and second one singleton set, a set consisting of single elements. So right, single elements, whatever you take 6, 7, and next 0, whatever 7, and you should take a negative values also. So right, minus n, right. So this is one element, so that is what more, that is singleton set. And next one, finite set. Finite means, so right, finite set means so which has finite number of elements, right. Next one, infinite set, which has infinite number of elements. Next one, universal set. So universal set is the most important, a set which consists of all the sets under the consideration, all and consideration, you should remember. That is universal set, also you denoted by capital U, otherwise mu is a Greek letter. So this is a universal set. And fifth one, so right, this is the topic today. And thank you, ma, and thank you everybody. So have a nice day. Thank you.